Hi ladies, here's your entry ticket. For the first question, you are going to want to make sure that you copy down this information and then use this solubility table that I will upload to Rediker to answer that question, as well as it's going to be used in the second question as well. So make sure that you take a screenshot or something of this specific table or pull it up on Rediker now. So I want to take the next 5 minutes to allow you to try these questions out and make sure that you start to use as much knowledge as you can from that chapter with ions and how to make new ions and new ionic compounds. So at this time you want to probably flip back to that chapter before you answer number 2. All right, go ahead and use the next 5 minutes and then we'll get to work. For question number 1, it's asking to predict whether something is soluble in water or if it is insoluble. So here's our latest chart, and this is one that you'll always have for yourself on a test, so you don't have to memorize all of this stuff, but you see some interesting information. The first one is if it is soluble. And if something is soluble, it will be denoted in green with the letters SOL. And if something is not soluble, it will be in red and it will be indicated by INSOL. Remember, soluble means it will dissolve, and insoluble means it won't dissolve. A good example of if something is soluble would be if you were to put sugar into your coffee, that is soluble, and insoluble would be if you were to put a rock into coffee. That rock is insoluble in that water. So now that we have those differences, let's take a look at number 1. We're predicting whether sodium phosphate is soluble in water. So to read this chart, you go to your sodium column, which is right here, and you want to probably highlight or circle as you get going. You're going to use that whole column, and then we're using just the phosphate section. So right here, where those two lines intersect, it tells you if that ionic compound is soluble or not. And you can see right here, it tells you it is in green and says the letters SOL. So remember, that means it is soluble. Now let's take a look at the next part of this question, and that is calcium carbonate. So once again, we're going to start by, let's first get rid of these old lines. We're going to start by highlighting your calcium column. And it's right there. And then your carbonate column. And where those two intersect, that is what is the property of that ionic compound. So here it intersects on the word insoluble, meaning it does not dissolve in water. So we're going to use this chart and this way of finding out this information to determine if whenever you dissolve two things into water and then combine them, if they will be soluble or insoluble and form a precipitate at the bottom of your beaker. So let's check that out. So let's look at number 2. To figure this out, we have to first of all figure out the ions. So in number 2, it's asking whether a solid forms when these two salts are mixed. And remember, anytime you're mixing salts, they are going to be in water, but we don't write the water since it isn't part of the reaction. And then if there is a solid that forms, we're going to write the net ionic equation. And it is just like writing a balanced equation, except instead of writing the whole compound, we're going to write the individual ions instead. So the steps to answer this question start with writing the ions of the reactants. And our reactants are shown right up here. They are silver nitrate and potassium sulfide. So to write the ions of this reaction, you can either use your ion or your periodic table and figure out the charges of each one of them, or do the reverse cross up that we've done a million times. And just as a refresher, if you had AgNO3, remember this is a polyatomic ion, so it's the quantity of them is over here on the outside of those parentheses. And then you would grab how many of each of them we have, circle, and bring them up to the top. Remember, the first subject or the first element that you run into, that is always going to be your positive one, and your second one will always be the negative. Now the charges will differ based on what number you are pulling up. So from this example, we can find that by pulling up the 1 on the outside of our our nitrate, you get a positive 1 ion for the silver. And pulling that bottom 1 up from your silver and putting it on top of your nitrate, your second ion is nitrate -1. So those are the first 2 ions of your reactants. The second set would be from your potassium sulfide. So if you were to take your K2S, again, we're going to grab the subscripts, remember ones aren't written, and pull those up to the top, or you can also look at your periodic table. And when you do that, you get a potassium with a +1 charge, because that 1 here down at the sulfite is being brought up. And your second one is your sulfur, and bringing that 2 up from the bottom will give you a 2- charge. So those are your 2 ions, your 2 sets of ions for your reactants. Now we want to figure out what combinations of your product are going to be formed. And the easiest way to do that is simply switch the positive ions and then do the cross drop down we've done a million times. And what that means is we're going to take Ag and your potassium and switch the spots. And by doing this, you're going to make your final product. So by switching your potassium and leaving your anions where they are, you would get something that looks along the lines of this. Now remember, to form that actual compound, you have to cross drop down. So that means you're taking your charges, taking just the number, and cross drop down to get how many of each you need in your compound. So whenever you do that for the first one, you have your potassium, which is K, bringing down the number 1, which we don't write. And then we have NO3, and once again bringing down the number 1, which we don't write, to give our final compound of potassium nitrate. The second compound that is formed is going to take the +1 and that 2 and cross drop down. Remember, we get rid of those charges after you drop down to finally give you the compound of Ag. We're going to take that 2 and we're going to put it as a subscript, and then your sulfur, drop down that 1, and remember we don't write that 1, sorry about that, and you get just your sulfide. So those are your 2 potential products. Now how do we figure out which ones are going to form a precipitate or be insoluble in that water? We have to check our new chart all the way back at the top. So our first one is potassium nitrite, and here is your potassium column right here and your nitrate column right here. And you can see where those 2 things intersect, that is soluble. The second option is our silver, that is with the sulfide. And there is our new compound that is going to be insoluble in water and be solid at the bottom of our beaker. So now that we know that one of these 2, specifically your silver sulfide, is going to be insoluble after the reaction, we want to perform the net ionic equation. All right, to perform the net ionic equation, I like to start out by first balancing the equation. And we've done this a million times, so I'm going to put in the numbers now. Now that it is all balanced and I wrote in the 1s just for your frame of reference, remember we usually don't write those, I am going to break apart everything into their ions. Now remember, you want to keep how many ions you have, so you want to make sure that you use your coefficients. So it's just like how we learned how to count how many of each element is there. So in your first example here, you have silver nitrate, which is AgNO3, and you have 2 whole compounds of that silver nitrate. So whenever you break it apart, that means that you have how many silvers? Well, you still have 2 of them. And remember to keep the charges whenever you are making your ionic equation. Ionic equations have charges, that's what makes them ions. And don't forget your second one, you also have 2 of those polyatomic ions of your nitrate. So 2NO3-. The second one's a little bit different because it has subscripts that we have to worry about. So we have potassium, and your subscript tells you that you have 2 of those, so make sure that you use the coefficient of 2, and it is a +1. The second one is your sulfur, Remember, your sulfur is a 2- by looking at the previous examples as well as your periodic table. And in this example, you only have one of them because there's no subscript and there's no coefficient higher than 1. So overall, we have 2 of each one of our ions except for sulfur. And that's going to create, sorry, I have to put a down arrow instead of a left to right arrow, your Ag2S, or your silver sulfide. Now, one thing that you must be very diligent about is that solids do not form ions. That's why we did the second step, figuring out which one's going to be forming a solid. So that means that our silver sulfide does not break apart in our water. That's because it is solid, it is at the bottom of the beaker, it's not going to be interacting with anything else. So there's your silver sulfide, and you already have one of those. It's going to be added to your potassium nitrate. Now remember, you're going to break those apart, and your coefficient says that you have 2 potassiums, which are still a positive 1 charge, and 2 NO3 minuses. Again, the charge hasn't changed, but how many of them is a little bit different. Once you get all of this done, you want to make sure it is still balanced. So if you were to count on each side, you still have your 2 silvers, your 2 nitrates, 2 potassiums, and 1 sulfur. Now, last but not least, we want to finish it off by making your net ionic equation by removing spectator ions. So by copying down what we have before, we'll get going from there. Copied this down pretty much exactly as I have it from the top, and I made it into one line. Now, to make a net ionic equation, all you have to do is cross out any ions that appear on both sides of your equation. So the first one that we run into is your silver, and there are silver ions on the left, but no silver ions on the right, so we have to keep that one. Now we're going to look at NO3. NO3 appears right here on the left as well as here on the right, so we can cross those out. The third one we come to is potassium. We have 2 of them, and there are 2 on the right, 2 on the left, and we can cancel both of those out. Sulfur, just like silver, does not appear on the right side of your equation, so we have to keep that one as well. To write your net ionic equation, you write everything that has not been crossed out. So that would be your 2 silver ions plus your single sulfide ion to give you Ag2S. Remember, since this is a solid, it does not break apart. And there is your final answer for your entry ticket. So today we're going to be doing questions from your book. Once again, they're going to be doing questions 23, 24, and 26 on page 378. Those are your questions for today. Answer key is already online, so make sure that you use that as a reference guide. And for tonight, you should be having a review as you have a test coming up at the end of the week. Have a good one.